Hello everyone. In today's video we are going to see speed time graph in kinematics for year 11 students. Let's get started. Speed time graph. Speed time graph can be used to find out how the speed changes with time. This is our speed time graph and our graph goes like this from O to A to B, B to C and C to D again. In this part from O to A, my speed is increasing. A line with the positive gradient, which means that the speed is increasing. In this case, my gradient is positive. What is my gradient? Gradient is delta y by delta x. This is the change in y and this is the change in x. So both are positive. In this case, my gradient is positive. Positive gradients will show you that your speed is increasing. From A to B, my velocity is not changing. That means I am moving with a constant speed. A line with zero gradient. In this case, there is no gradient we have, which means that the speed is constant. I am going with the constant speed here. From B to C, the steeper the line, the greater the acceleration. Here, I am going much steeper. That means my speed is more faster than from O to A. If my speed is faster, that shows you that my acceleration is greater. From C to D, I am deaccelerating. My velocity is coming back to zero. A line with the negative gradient means the speed is decreasing. In this case, my gradient is negative y because gradient is change in y over change in x. This is my change in y, which is positive, but this is my change in x, which is negative because I am going in the negative direction. This shows you that from C to D, my gradient is negative. When your gradient is negative, that means you are deaccelerating. This shows you that your speed is decreasing. The gradient of a speed time graph represents the acceleration. The area under the speed time graph represents the distance. If you find out the area under this graph, this will tell you the total distance covered by the particle. Let's see velocity and acceleration here. What is velocity and what is acceleration? If a particle moves in a straight line with displacement function st, then the rate of change of displacement with respect to time is ds by dt, because I am differentiating the displacement with respect to time, is the velocity v of the particle at time t. So my velocity will be given by differentiation of the displacement with respect to time. If the velocity function is vt, then the rate of change of the velocity with respect to the time dv by dt, I am differentiating the velocity here, is the acceleration a of the particle at time t. So my acceleration will be given by dv by dt. That means I am differentiating the velocity function. What is my velocity function? My velocity function is in terms of s, which is ds by dt. If I replace this v by ds by dt, that means I am double differentiating this one with terms of displacement. My acceleration will be either dv by dt, or you can say double differentiation of displacement, d2s by dt square. Let's see one example here. Consider a particle p traveling along a straight line such that its displacement s meters from a fixed point O t seconds after passing through the origin O is given by s is equal to 4t minus t square. The graph of s against t is given from t greater than 0 to less than 5. This is the same question. I have picked it from the previous video. If you have not watched it, please watch it. This is the graph of displacement time graph. From this graph, find an expression in terms of t for the velocity v meter per second of this particle. What is my s? My s is given as 4t minus t square. This is my s. I need to get the velocity function. Velocity function will be given as differentiation of ds by dt. Let's differentiate this function. d by dt of 4t minus of t square. This will be written as d by dt of 4t minus of d by dt of t square. 4 is a constant function. Differentiation of t with respect to t is 1. Let's write it here. This will be 1 minus differentiation of t square is 2t. Substitute here. My answer will be 4 minus 2t. This is my velocity function. Let's see the next part here. Draw the graph of v against t for t greater than or equal to 0, less than or equal to 5. From this displacement time graph, I need to plot the velocity time graph. Velocity is 4 minus 2t. I need to plot this function from 0 to 5. Let's find out all the values of the velocities from time t is equal to 0 to t is equal to 5. When t is equal to 0, I need to substitute t is equal to 0 here. The velocity will be given by 4 minus 2 times 0. My velocity will be given as 4. Let's substitute 1 here. Velocity will be given by 4 minus 2 times 1. This will be equal to 4 minus 2. My velocity is 2. In the same way, if you continue that, when you substitute t is equal to 2, your velocity will be 0. When you substitute t is equal to 3, your velocity will be negative 2. When t is equal to 4, velocity will be negative 4. When t is equal to 5, velocity will be negative 6. Let's plot all these values here on the graph. If t is equal to 0, my velocity is 4. T is equal to 1, velocity is 2. T is equal to 2, velocity is 0. T is equal to 3, velocity is negative 2. T is equal to 4, velocity is negative 4. T is equal to 5, my velocity is negative 6. This is my velocity time graph from the displacement time graph. Let's see the questions here. State the value for t for which the velocity is positive. Where we can see the velocity is positive. In this part here, the velocity is positive, but 2 is not included. At 2, the velocity is 0. My values of t will be greater than or equal to 0 and less than 2. 2 is not included. Let's write down the answer here. T is greater than or equal to 0, less than 2. That will be my first answer. Let's see the second part here, when the velocity is 0. When your velocity is 0, your velocity is 0 at time t is equal to 2. Let's write down answer here. T is equal to 2 will be my answer. Let's see the third part here. When it is negative. Let's see the graph here. Velocity is negative in this portion. Is 2 included? No, right? All the values greater than 2 and less than or equal to 5. Let's write down the answer here. T is greater than 2, less than or equal to 5. That will be your answer. Let's see the fourth question here. What can you say about the direction of motion of the particle when the velocity is positive? When the velocity is positive from greater than or equal to 0, less than 2, what you can predict? You can predict that because velocity is positive, we can say that we are moving in the positive direction, or our gradient is also positive in that case. It shows you that you are moving towards right. Let's write down the answer here as you are moving towards right. What you can say about the direction of the motion when the velocity is 0? At t is equal to 2, my velocity is 0. When velocity is 0, that means I didn't move. That means it shows you that my position is stationary. This shows you that at 0, the velocity is stationary. In the third part, what you can say about the direction of the motion when the velocity is negative. Velocity is negative from greater than 2, less than or equal to 5. In that portion, we can say that we are moving towards left. Let's write down the answer here. Moving towards left. You are going in the left direction. Let's see the next question here. Find the acceleration A of this particle and interpret your answer. I need to interpret by looking at the acceleration. Acceleration will be given by differentiation of velocity. What is my velocity function? Velocity function is 4 minus 2t. Let's differentiate this function to get the acceleration. Acceleration is dv by dt. Differentiate this function with respect to time. 4 minus 2t. This will be written as d by dt of 4 minus 2 is a constant function, d by dt of t. Differentiation of the constant function is 0 minus 2. The differentiation of time with respect to time is 1. This will be 1. My acceleration will be negative 2. In this case, my acceleration is negative. What does it show you when your acceleration is negative? When your acceleration is negative, this shows you that your velocity is decreasing. This interprets that velocity is decreasing. That will be your answer. Let's see some results here. Signs of displacement S. what you can interpret with the sign of the displacement. When s is less than 0, that means it is negative. It shows you that particle P is to the left of the origin O. You are standing towards the left side of the origin. When s is equal to 0, this will shows you that the particle P at the origin. When s is greater than 0, this will show you that the particle P is to the right of the origin. You are standing on the right side of the origin because your displacement is positive. Signs for velocity v. What it will show you with the velocity function. When velocity is less than 0, that means it is negative. It will show you that the particle P is moving towards the left side. When the velocity is 0, this shows you that the particle is instantaneously at rest, or you can say that he is stationary. When velocity is greater than 0, this will show you that particle P is moving to the right direction. Let's see the signs for acceleration A. Acceleration is less than 0 when acceleration is negative. This will show you that the velocity is decreasing. A is equal to 0. Acceleration is equal to 0. When acceleration is equal to 0, this will show you that the velocity could be maximum or minimum or constant. What is the meaning of that? Either your velocity is maximum, or you can say that it is at the minimum point, or you can say that you are stationary at this position, or you are moving at a constant velocity. Acceleration is greater than 0. Acceleration is positive. This will show you that the velocity is increasing. Thank you so much for watching. I hope you enjoyed my video. Don't forget to like, subscribe and leave a comment down below. Bye bye everyone.